So, hi everyone. Very nice to see this big crowd here, and congratulations for the organization for setting this up. Very nice talks until now, and I loved that on the last talk you started by saying that you came here also to learn, and not only to share something or to pass knowledge to other people. And in fact, I think that sharing is part of the learning process. So I also have the same feeling as you. So I'm here to share our journey towards continuous delivery at OutSystems, which I will explain what is OutSystems for those who don't know. So first things first, who am I? My name is Diogo Oliveira. I came from Portugal, and I'm a software engineer at OutSystems R&D, specifically at our DevOps group, let's say, which is a group that is focused on ensuring that all the processes and tools are in place so that we can have continuous delivery practices and automation and stuff like that. I will get to this later. And I'm also one of the co-organizers of the Lisbon DevOps meetup, which is a meetup we are doing now for some months already. And our ultimate goal of this meetup, by the way, is to be able to organize a DevOpsDays in Lisbon. We never had one in Portugal, so I also came here to learn about the event. So, about OutSystems. What is OutSystems? How many people here know about OutSystems? Anyone knows? Nobody? Cool. Cool, not cool, but cool because I will explain what is OutSystems. So, what we are doing, OutSystems is an international company, and its R&D is based in Portugal. And what we are doing is creating a low-code rapid application development platform that consists on an entire application management lifecycle. So you have, for example, you design your applications using a visual language, then you have monitoring applications, management of your environments, a lot of other stuff. I will get there. At this moment, we have around 400 employees all around the world. And at R&D engineering, we are 100, more or less. So, about our product. I won't get into much details here, but this picture is important to explain the complexity of our product and why we had so many challenges that I'm going to explain next. But basically, our product is in fact a set of different products that are all packaged in one. So, for example, we have Service Studio, which is our IDE, where developers can, using a visual language, develop their products. Then we have some front-end applications for monitoring and environment management. And also we have our server that manages all of this. And we are offering our product both as an on-premises solution or a cloud solution. About the supported stacks, and this is another important point of complexity. So our product, we try since this is a low-code platform, we try to abstract a lot of stuff. So, for example, the connections with databases, for example, are completely transparent for the developer. It's exactly the same if he's developing using MySQL or SQL Server or Oracle. The way he interacts with the software is exactly the same. So we need to have a lot of supported stacks in the backend of our product. So we support different operating systems, different core languages, different databases, and we integrate with a couple of external systems like SAP and Salesforce and others. So this was the big picture about our product. And now, how are we developing it and ensuring its quality? So first of all, the main language that we are using to develop is Microsoft.NET C#. And we use many others, like Java, TypeScript, JavaScript, and F# for parts of our compiler, and many other languages. And we have something very particular about the way we develop, which is also very important for the way we ensure quality, which is on the server part of our product, we support both the .NET and Java stacks. And at first, it was very hard for us to be able to maintain and develop both versions at the same time. So what we did was we created inside the company a translator, a code translator that translates our code from Microsoft.NET C# to Java automatically. automatically. On some situations, you need to verify some stuff, but it's pretty much automatic. And it translates not only the code, but also the tests. And this is being done for around 80% of our Java code passes through this process. The other 20% are really coded in Java. Another thing we are always trying to do is that we try to abuse on dogfooding. So some parts of our product are developed using the product itself. So basically, all our front-end applications of the product, for monitoring, for example, we use the product itself to develop them. So we are actually the first ones to test the product and the ones to suffer the pains of the product if it has any pains, so that we can tackle them sooner. And also, inside our engineering R&D, we also have a couple of internal engineering applications that we also develop using this product. More than that, so now we come to the quality part. So we have around 10,000 tests that are fully automated, and these 10,000 are distinct tests and for each major version of our product. And they are developed in different technologies and frameworks, like JUnit. We use Karma, Selenium WebDriver, and other frameworks that probably many of you already know. And we also try to use a lot EAP versions, which are early access program versions. So we have a set of customers that experiment the product first before it reaches the market. And we lately have been trying to do a lot of alpha and beta versions so we can get more releases and the product out more times and more frequently. So this was a big picture of the product and the way we develop. Now let's get really to the topic of this talk, which is our journey towards continuous delivery. So let's get back 10 years first. I brought a time travel machine here. So we are now in 2006. And at this point, we were a relatively small team. We were developing a small product, relatively small product at the time, and we had no tests at all. So basically, we had tests if something really was very bad and was broken on the customer. Let's make a test to make sure that this never happens again. But apart from that, we had no tests. And with time at this point, so as I said, our product was small in 2006, but then, okay, we have some requests of customers that would like to run the product in Linux, so let's support multiple operating systems. Let's support now another database system that we need, and another language, and now another rendering language, and now that's support for different browsers. So the complexity of the product in terms of what we needed to test and to make sure that that was working really started to grow at this point. And first of all, we had no tests, so this was the first problem. And even if we had, our developer machines were like Windows machines with Visual Studio installed and stuff like that, so it was really hard to test all the possible stack combinations on their machines. And it was very hard to manage the tests. So at this point, we created something. We created a test management and orchestration tool. So it was basically a place where we had all our tests and we could manage the tests, and then we could orchestrate their execution on different test environments, which had different configurations according to the stack we wanted to test. And this was actually for us better than anything at the time. So this was amazing for us, and this was in 2006, I say again. So this was really saving a lot of trouble for us and doing a lot of monkey job for us, let's say. But now, okay, so some years passed, namely 8 years. So now we are in 2014, 2 years ago. And this tool was something that solved our problem initially, and as I said. It kept solving the problem because people were very tolerant to pain and suffering, and I will explain why. This became the only thing that was grieving as the green ship it light. So only when all the processes and tests on this tool were green, we had some guarantees that we could release the product out there. So we were highly independent on this. It eventually started testing too much because people actually, I forgot to say this, but people actually started to make tests in these 8 years that passed. So this we eventually started to test too much. We had too many tests. And this was an open tool for the R&D. So it was being evolved by everyone without a clear vision. So each guy that wanted a new feature there just went there and created a new feature. So now it is like a Frankenstein stuff, very strange. And also in 2014, something happened in the company. So 1 year before, in 2013, we were 18 people at the R&D department. In July 2014, we were the double, so we were 41. And I can give you a fast-forward tip that in 2015, we were 85, and now we are around 130 people. So, and this was very important for us to notice that we needed to change the way we are doing things, and I will explain this right after. So also at this point, about branching and the way we were doing code, so teams were working on separate environments, and this was being achieved using branching, and we were using SVN, and we had 30 active development branches as of November 2014, so there were actually 30 alive branches under development, and this was like hell, basically. So because we needed to reintegrate the code to the main branches to make a release, and we had 30 branches to reintegrate to 1 or 2 main branches. People were spending weeks doing this kind of stuff. And about the quality assurance, we had a big challenge here. So that 10,000 tests I talked before, in fact, in terms of executions, they become like 100,000 because of all the possible stack combinations that we have. For example, a test can have a different behavior if we are running a SQL Server database or if we are running Oracle. So we have to make sure that the test is actually working with both databases. And so our tests was in fact being unfolded in many tests. And how were we running tests? So we had a black box. We were basically orchestrating a full run and full build and full test run on our test environments for all the combinations. And this was being done initially daily, then the daily stopped to be enough. And this was really a very long feedback loop. So from the point I, as a developer, committed until I know if I broke something, it could actually pass days or weeks even in some cases. So this, if we try to run all the tests followed in a full run, in 2014 it was taking 26 hours to run these 10,000 tests in different stacks. So we had really not a daily visibility. Our build system was also very slow. We did not have incremental builds. It was always a full build, and this is a huge product, so it was very hard. Our test environments were very, very unreliable, and I will get there soon. We had a lot of flakiness on our tests, so a lot of tests were unstable, and some of them causing problems on other tests, which is also a problem. So we had lack of isolation. And overall, our feedback loop was very long. And as I said before, we were executing 100,000 tests every time we attempt to do this full run. So now I talked about unreliable test environments. So how were our environments? So I already talked about the testing management and orchestration tool. I didn't talk about the environments. Well, this part was also something like, if a developer needed a machine to test a new stack, or if, for example, a bug appeared on a customer and he needed to validate that specific task, you would go to the operations team and tell them, okay, I need a test environment with Oracle wherever, for example, to run some couple of tests. And the operations guy would say, okay, I will ask a machine first to our infrastructure department, which was a company-wide infrastructure department. So eventually in 2 weeks, we will have the machine. And after those 2 weeks, I will spend 3 days configuring it using our 49 pages long manual. And this is true. The manual really had 49 pages. It had basically the configurations for all the possible stacks, but it was 49 pages long. And also another problem, so being a manual process and taking so long is already a problem, but apart from that, the fact that this process is very long and manual, it also made that each test environment was like a snowflake. So each one of them was very unique because it was like craftsmanship. It was handmade stuff. So you really had to take care of the machines and make sure you wouldn't break them. Because if you did, someone would spend 3 days again reconfiguring it. So, to sum it up, where were we in 2014? So, as you can imagine, this was not anything near continuous delivery integration or whatever. But at this point, we were only releasing one major version per year, and we had 2 versions usually under support, but only with corrective maintenance. So, for the frequency we needed to release, this was really not being a huge problem. So I can say we were living quite well with it yet. So why did we need to change something? Okay, there were some things here that made us change. So first of all, we took the decision that our maintenance versions would not be, we would start making features for that version. So our patches would also release features and not only corrective maintenance. And this had more requirements in terms of testing and quality. The amount of development going on increased a lot. So as I told you, we were 18 in 2013. Now we are 130 people. So we have more people working, more people developing, more tests being done. So we really have more things going on at the same time. And that full run was not enough anymore. So as I said, we first attempt to run it on every night. But it's actually taking more than a day already, so we were not being able to catch up. So we understood that we would need to have faster feedback. This was not enough for us, and we needed it with quality, not only fast. But we knew that our processes, our tools, and our infrastructure were not in place for that. This is like the metaphor of a frog in boiling water. I don't know if you're familiar with it, but it's something that if you put a frog inside water and you start eating the water, when the frog perceives that he's eating, he's already dead. So, and this was something that could have happened to us. So we were on boiling water, we were eating. We would need fast feedback very soon, but we knew that we were not ready. Eventually, we were able to hire a smarter frog at this point, and we were able to understand some things. As I said, we really understood that we needed to do something. If we wanted to have faster feedback, if we wanted to release more frequently, we needed to start building something at this point. So what did we do? So first of all, as we should always do, we started by analyzing the problems, all the problems we had, which were a lot, prioritize that problems and reach some alignment. So let's start doing things. So the first thing we did was automating the way we were provisioning our test environments. And we used Chef for doing this. So all that 3 days that I talked about of one person were gone now. So no more 3 days working on creating a configuration for the machine. And also, this was much easier for developers to keep the infrastructure code updated, because it's code after all. And before, the process was, there was that 49 pages long manual, and people needed to request to update the document if they wanted to change anything, which was very bad. But okay, still some problems here. We have the test environment configuration automated, but we still need to wait for those other guys to create the machine, and which would take 2 or 3 weeks still. So we still had a lot of problems there, and how can we solve this? So those guys of the infrastructure were working for the whole company and provisioning machines for the whole company, all departments. So, and they had very few people working there, so they really did not have hands enough to handle all of this. So we created another project after that one of the automation, which was the Nimbus project. That's the name we called it, which was basically a project where let's move our testing infrastructure to the cloud. Let's have things in the cloud. We will not depend anymore on these 2 or 3 weeks. And we did it. And so what we achieved very fast after doing this was, instead of 3 weeks, 2 or 3 weeks plus 3 days of a guy configuring the machine, now it's all in 1 hour in a click of a button. So, and this 1 hour includes not the creation of the machine in AWS, but also running all the scripts to configure the machine. So now, anytime a developer needs a machine, it just needs to click a button and the machine in 1 hour appears. For one stack, we started doing this for one and 2 stacks now. We are still working on the others, but they were the most common ones. Also, these machines are not snowflakes anymore, so they are easy to recover now. You just need to recycle the machine or just kill it and create another. It's 1 hour, so not a big deal. They are much more reliable and performant than the machines we had in-house, on premises. And also, this will allow us to scale and to have elasticities if we suddenly need to have more machines and more environments. So we already have our infrastructure part more or less solved, but we still needed a lot of other stuff there. And one thing we did was we usually have knowledge transfer sessions that among the company that are done during lunchtime. And some guys from our team decided to make a knowledge transfer session about continuous delivery, basically to explain people what was continuous delivery, why did we need it, why was it important, and how far were we from it. And this was not our idea, but this actually had a huge impact on our developers. They started to think a lot on a lot of stuff. And so some of those developers, they all look like this, by the way, they went to their managers and they said, hey, we are really excited about this continuous delivery stuff, and we had an idea. Give us 1 week to try to do something. And we will save you eventually like 3 months of wasted effort. And the manager said, okay, go for it. I want to see what's coming out there. And so what they did was on that week, they created something called CINTIA, which stands for Continuous Integration and Intelligent Alert System. It was the name they gave it. And they started to call this CINTIA system a monkey. And this was a monkey because this was automating a lot of stuff for them. Basically, this was automating the builds, and the builds were now incremental and not anymore full builds always. We were also automating the installation of the parts of our product. We started to add some automated tests to this system, only 1,000 to begin, because this was a POC. And another very important thing is that this system was automatically assigning the failures of the tests and builds installations to people. I will show you a picture of this. And this was developed using our own product for the UI part and Python for the orchestration backend part. And this was the first UI of this system. So basically, you have there the status of the build, installation, and tests, for example. And the tests that are failing have the faces of the guys whose commits might be related with that failures. So since people have their faces there, they feel some pressure to start actually fixing the tests. So what did this system bring at this point? We were able to build, install, and run 1,000 tests in around 19 minutes, and this was automatically triggered by commits. Basically, we were polling SVN, and every time there was a commit, it would trigger the system. We had fast feedback on a very small scale still, but we had something at least. And we had this automatic culprit assign fast that was very important for us. This thing of the faces, many CI systems don't have this, but this was very important for us because people were spending a lot of time just trying to understand who might have broke something. And this was giving us that for free. But well, this was a POC, as I said. How could we make this a more real CI system? So how can we achieve fast feedback if we know that our 10,000 tests are in fact going to represent 100,000 test executions? And we started to question ourselves. Do we really need to run all the tests for all the stack combinations every time anyone commits? So we know that some of our stacks more customers have than others. So we have stacks that are more main and others that are more outsiders, let's say. And so we took a decision here. Let's apply some risk management at this point, and let's do the following. Let's run all the tests for 1 or 2 particular stacks only on this system that triggers on all commits. And let's run all the other tests weekly on particular milestones and prior to releases. We did this, but we still had some problems. So even by taking this choice, so we reduced the scope of the number of tests we needed to execute a lot already, but we had some problems. So first of them, we were reinventing the wheel again by creating our custom backend Python code to do a CI system. Because as you might know, there are a lot of systems out there that already do this kind of stuff out of the box. So we were reinventing the wheel. and usually pay the price when you reinvent the wheel. We still had too many tests, even if we cut the stack, so the feedback was still not so fast. We had, I say here, unclear test categorization, but it's not unclear, it's basically inexistent. We had no test categorization, no unit tests, no integration, we had tests, basically tests. And all the tests were the same, and this was leading us to a monolithic test stage, and we had a lot of instability on this. So how did we solve these challenges then? So first of all, we started using an open source CD tool to service the backend of our system. This tool is Go CD from ThoughtWorks. I don't know how many of you out there know it. And for example, Jenkins is much more well-known than this tool. But we started experimenting this tool as a POC, and we are actually very, very satisfied with using it, so that's why we did not feel the need to change. And so that pipelines that are on that UI are basically orchestrating on these pipelines. And now this is the new UI that we have today, where we attempt to solve some problems here. So first of all, I told you that we did not have, all the tests were on the same stage, so the feedback were not so fast. And as you can see now, we have 3 test stages that run with different speeds. So the first one runs in 10 minutes, the second one in half an hour, and the third one now is running in less than 1 hour. And since I said that we have no clear separation of unit integration, you might ask, so how were you able to do that split? We did it in the way we could, which is let's measure the times the tests take to execute. And let's put the faster test on the first stage, the less faster on the second, and the slowest on the third. And we did it. So at least we are maximizing the number of tests we run as soon as possible. And also we started to use some parallelization here, because without parallelization, this was still taking hours, and that was not enough for us. So this means that now when a developer commits in maximum like 1 hour or 1 hour and something, he knows the feedback of his commit. Another problem we had, very huge problem, was the flaky tests, because people were spending a lot of time troubleshooting failures that were not actually real failures. It was just misbehaved tests and tests whose result changes with some flakiness. So we have that symbol of the dice there. We are basically, every time a test fails, we execute the test 3 or 4 times again with the same revision. And if on any of that runs the test passes or changes its result, we are flagging the test as flaky. So people at least now know who are the flaky tests, so they can tackle them. And we also have the quarantine tests for tests that were, for example, blowing up our pipeline. So people can quarantine them. And the quarantine is limited to 7 tests. People can have more than 7 there. Because if they started to do it, eventually all the tests would be on quarantine one day, I know that. And about CI culture. So we had this cool UI and custom stuff, but how can we motivate the people to fix the issues? How can we make sure that they are fixing it? The best way is to give visibility to them. So we did that. We have a couple of TVs around the office, and this is on that TVs always turned on. I don't remember how many TVs we have now, probably 4 or 5, that are always rotating are always rotating these 3 tabs. So people always have visibility. And when their faces are there, people feel pressured. I want to take my face out of there, so let me fix the test. Let's call it a positive reinforcement, not public shame. It's a matter of perspective. But we still had more challenges here. Despite the fact that we have these TVs, people needed more feedback than only knowing the test was failing. So why the test was failing and how can they troubleshoot it? So we added some more stuff here. So now if they access this page on their computers and click on a test, they can see the failure message, the stack trace, and they can, for example, look at the console of the execution of the test, the environment it executed, and they can run the test locally, for example. And we were inventing something of our own because we thought that this was fitting our purposes. Well, what if something misbehaves? Now we have a lot of machines, we have parallelization. How can we deal with this? So we were using Slack for communications on our internal R&D. So we just decided to create a channel which would receive notifications when any machine misbehaves or tests are not running as they should, or stuff like that. So now we reach today, finally. So let's now look at the numbers and see where we are now. So as I said before, 2 years ago, we were taking 26 hours to execute 10,000 tests, and with a lot of problems, flaky tests, slow builds, long feedback loop. And now we have around 8,000 tests executing in 1 hour for 2 stacks. And the 8,000 tests is because we had 2,000 tests that were developed using our old test management and orchestration tool that added our own DSL, so you could make tests there. And that was the worst idea ever, because now the tests are really stuck to that thing. So what we are doing is we are motivating people to refactor the tests and make them real code tests instead of using that DSL. So we are still on this process. And now we are having visibility every day. We are having fast and incremental builds. And we are focusing more on creating fast and good tests. And we have an overall feedback loop which is greater than there was before, and we are very happy with what we achieved until now. So just to finish very quickly, we still have some open challenges for the future, which I would like to share with you, because probably some of you also have these challenges, and it would be nice for us to exchange some ideas. So one of the things is that our product architecture is not, we are not using microservices. Our product architecture is very monolithic. So it's very hard to, for example, if I only commit on this particular part of the product, why do I need to run all the tests? And we are running all the tests now. So we need to work on aligning the validation with the product architecture. We need to work on ownership. There is not a clear ownership of parts of the product, so it's parts that everyone is touching, but when something goes wrong, it was nobody's fault. We need to have not only a lot of tests, but the right tests, the ones that ensure the quality of the product. We need to refactor while the train is moving, so we still have to deliver our product to our customers, and we can't stop doing that. So we have to do all of these while moving. We are now trying to work on a single branch per merger version. We actually are already doing this, and it's working quite well. And for sure, we need to improve the culture and mindset. People break things, they really need to fix it, and this doesn't happen always. And we want to take developers out of the release decision. This means that our tests and our validation processes should be enough for us to make sure that our product is good to get out. So we want to achieve continuous delivery, and if we were climbing a mountain towards continuous delivery, I would say that we are somewhere near that place. So we still have a long way to go. So I would also like to hear feedback from you. I'll be around there. So thank you for the presentation. I took some minutes more. Sorry for that. So thank you.
Thank you so much.